we are slowly on time, getting to 9 a.m., and we are going to welcome our first speaker. I'm very glad to welcome him because I know him personally. We've been working together. So Kamil Witecki will be telling us to embrace Docker Composer and stop worrying. Current engineering manager of Snowflake, who still codes and solves technical problems with strange sympathy to Lua. And, the big fan of doing the right task by the right tool and not going with the hype. And what is interesting, a competitor and judge in International Practice Shooting Confederation shotgun matches. So, Kamil, the stage is yours.
Thank you very much. Hello, ladies and gentlemen. I'm Kamil Witecki, and currently I'm working for Snowflake as a manager. But I have been working as a programmer and architect for ages for both Snowflake and Nokia. And today I would like to show you and try to convince you to do testing with Docker Compose. Before we start, I have mentioned Nokia, I have mentioned Snowflake. Just to be sure, the opinions that I will share with you are my own and not necessarily endorsed by any of these companies. Before we start, who here knows Docker Compose? Who used it ever? Okay, like half of the room. Who has used Docker in any way? Okay, it checks. More hands are in the air. Who knows more or less what Docker is in general, like what are containers? Still, some persons didn't raise a hand. No worries, you are still in a good room. I will go slowly and I will explain the basics, and you can work it out from there. So you are in a good room, you are up to learn something today, and that's why we are here. And what I would like to tell you about is that, first of all, integration testing is cheaper than you think. People always told you, no, the more complex testing you do, it has to be way more hard. No, it's not true, and you will see that return of that investment is worth it. Then you can run your whole stack in hermetic environment. Every time you try again, you get the same results. In integration testing with real database, with simulator of cloud provider, whatever that is, you can have full stack in hermetic environment. Then you will be debugging real production interfaces and not your assumptions. How often have you faced a situation when you are interacting with a third-party application and it didn't work quite as you thought? This is the way to do it right, because you will be integrating with the real thing and not with your own assumptions. Last but not least, we will be building our reports like a pro. So your Jenkins or other CI/CD tool will be happy about it. Now, you are probably familiar with the testing pyramid. Have you heard about it? Raise your hand. No! Oh, wow. I expected like full room of hands in the air, and I got like few. I'm surprised, but let's see. So the testing pyramid, as it was established in 2000s, said that you should have a lot of unit tests, less integration tests, less end-to-end tests, because they are allegedly more costly to execute, to create, and the complexity grows, and they are not so really good in finding issues. So these are myths. Like one myth is that locating a bug in integration testing will be slow. In unit tests, it's very simple. In integration testing or end-to-end testing, it will be so hard that you won't be able to do it. And that's not true. Because if you are using right tools, like Docker Compose and development containers, you will run your application in IDE with a debugger, you will set up your breakpoints, and you will do with it whatever you want. So you are getting more or less the same experience as you do with unit tests. It's not harder. It's different. Yes, you need to learn new tools, but effectively, it lets you do it on par with unit tests. Another myth is that execution time is slow, but why is it slow? You need to ask yourself that question. And it's slow because your application is slow. And the fact that you are running your full application and you notice that slowness enables you to profile it and debug it. Do not run from it. This is the value, and this is why you should do integration testing. And last but not least, maintenance of such test cases is allegedly order of magnitude harder, and we are in this room to show that this is not true. It is quite easy if you use it right. And what I would like you to understand is that it's not about how many test cases you run per second or a minute. It's about how many true positive issues you find in your code. You can have thousands and millions of test cases of unit tests that do nothing, that are checking getter and setters, and effectively give you no value. What we are really worried about in testing is making sure that we find errors in application. This is true return of investment, and this is why you should be doing integration testing, because otherwise we end up in this situation. So how to do it? I will show you first an example of a single test case. So it will be simple, there won't be much moving pieces, just to give you the concept, and then we will build on top of that something more complex. And now, when it comes to single test case needs some structure. And each test case is more or less the same. No matter if you are doing unit testing, end-to-end testing, integration testing, you need these parts. So setup, trigger, and verification. You need to set up your environment. You need to start mocks, simulators, whatever you have. You need to preload your default data. And last but not least, you need to make sure that your environment is the same every run, because otherwise you will be getting different results, and then your testing is unreliable, and then you really don't get much value out of it. So set up everything like fixtures, simulators. This is this step. And once we are done with a setup, we are ready to trigger specific scenario. And triggering something is up to you, because it's your application. It will have some interface that you know. It might be REST API, so you will call it via curl or whatever else. It might be gRPC. You will use gRPC curl, anything just to trigger your application. It can be command line application, and then you will just call it. Whatever that is, this is the moment when your application runs. And so that trigger might also return some kind of a status, like an exit code or HTTP response, and you will be able to validate it here. But this is a very small part of verification, because what comes next is the verification step, where you are actually finishing what you expected to do by the trigger. You are somehow detecting that, okay, this is the moment, and you are now verifying things. And this is probably the most important part of the testing. You stop and you check, okay, my database, is it in the state I expected? Did somebody remove a row that shouldn't be removed? Did somebody add something to the file system that shouldn't be there? Did we leak any secrets in the logs? This is the moment. So verification after the scenario has finished. And how can we reflect that structure into Docker Compose? So let's put it all together. First of all, simple things like our setup. Let's start, in that case, local stack simulator. This is a simulator of AWS services. For Azure, you have Azurite. For GCP, you will have different emulators from Google. And this is cool that they are the ones providing it, because they know the product. They can give you something that works more or less the same, like the real thing. Few years ago on Code Dive, I was giving a presentation and I was trying to convince you that you shouldn't be writing mocks for external services, but rather you should be providing mocks with your service. And this is a great example how it works. The company provided you simulator like Azurite coming from Microsoft, and you have guarantee that it works just like Azure would. In that case, we are setting up a service. The name of the service is s3 localstack.cloud. We will be using the image localstack, and we will be setting some environment variables Like we want only one service, S3. That's it. This is the very simple example how you can run a service and you will have it there. What is also neat about Docker Compose is that your name of the service becomes a DNS name. So from now on, you can refer to your S3 just by using AWS S3 Local Stack Cloud, and it will find it. Now, if we want to make it a little bit more complex when it comes to network, we can add aliases and we can export ports. We need aliases because how AWS API works. Internally, when S3 is referring to some bucket, it will rewrite the URL to something like bucket localstack.cloud. So we need to add alias so that the DNS can actually resolve to the right service. And this way, we have run full S3 simulator. That's it. We don't need anything more. We can connect to it and use it. Similarly, if you need real database like Postgres, just start an image Postgres, set up some environment variables, and you are good to go. What is cool is that Docker Compose will pull these images for you from the registry. So if you don't have them on your laptop or your Jenkins node, it will try to find them for you anytime you run a test case. If it finds it in your local registry, it will use it, and we will use that because we will be exporting our application that way. Now, if we have fixtures, we can call different commands on specific applications. So here we have db fixture, and what is new in that example is this command. So we are using image alpine PSQL. This is very small Linux with client of PostgreSQL, and we will be giving it var database dump. It's basically running this command through bash, as simple as that. But now, where does this database dump come from? We need to somehow mount it to the container, to the service. And we do it using config sections. We tell it that on local disk, in the context where we have run Docker Compose, we have directory fixtures, there is a file database dump that should be mounted as a target inside of the container, var database dump, with a proper mode. Simple as that, and thanks to that, you can have all your fixtures, all your data kept separately from the actual configuration of Docker and version in your version control system. And when it comes to dependencies, of course, if we are loading something to the DB, we want to be sure that the database is working. And this depends on section comes here handy because it lets you connect the dots. I have database here, I have database fixture here that loads the data, and I want to make sure that fixture runs only if the service has started. Depends on service started, and we are good. Docker Compose will track dependencies for you. We'll use it extensively to chain our test cases, to chain our verification after trigger. And very similarly, we can do about S3 data. So we will be using just different image, AWS CLI. We will tell it what is the endpoint. So we don't want it to connect to actual S3, but to our local stack. I told you that the names are resolved by the DNS, and this is an example how we use it. Simply HTTP S3 local stack cloud, and all your AWS requests will now go to our simulator. Again, it depends on S3 local stack service because we want fixture to run only if that service is already running. There is also different value called service healthy, but we will not go into health checks today. You can look it up later on, and this gives you a little bit more confidence that everything is okay, because if your simulator stopped or your simulator is misbehaving in some way, health check lets you verify that. For the simplicity of the examples, let's roll with the service started only. Now, since we have set up the environment, we are sure things are there, it's time to start our SUT. And what I'm using here, I'm again setting the environment, so an address of AWS. I'm using the image, my fancy app latest. And this is where you need to probably do some changes. You need to make sure that your application can run inside of a Docker container. You can achieve it in multiple ways. One, use Docker file, build application inside Docker, expose it, that's it. Another option is use Bazel to build your images in a tar format and import them. It's up to you, but what's important is that you need that application to be an image or to be buildable as image, because image is just one type of entry. You could use build command, and it would have built a local Docker file and use whatever image results from that. Up to you. I prefer to separate these steps. This is my build. If it's green, I am testing. If you mix it, then you have no idea if your SUT didn't run because there was some error, or it didn't run because the build didn't work. So my personal opinion, separate the steps. First, build, export to your registry. If everything is OK, move on to testing of a build application. And here, new thing. Depends on section has a new value, service completed successfully. So we are still depending on something, in this case, on our fixtures, but we want to be sure they already completed working. We were preloading data, we were setting up something, and we want to be sure that this setup is completed. Service completed successfully is exactly that. If any of these commands exceeded with anything else than 0, it means it didn't exit successfully, and we are not able to run this service. So the whole tree of services will stop spawning. So if your fixture fails in that case, the SUT will never run. And we will use that fact to build reports later on. And it also saves you resources, because if setup fails, you are not even starting your test cases and you are failing fast. And this is also something that you want, because if you fail fast, then you can iterate fast. You detect error fast. So it's time to trigger something. Our application is working, SUT has started, let's do something about it. And this is a very simple example where we, again, are using different image. In this case, it's well-known curl from standard Linux toolset, packaged as an image for Docker, and we are calling simple HTTP call like status. This is basic health check of SUT. Of course, it needs to depend on SUT. The SUT must have started, but that's it. And last but not least, we'll be verifying things. If trigger SUT completed successfully, check what's inside of the database. Again, the command can be anything. And when it comes to commands for verification, they are usually getting quite complex. So you will be verifying multiple things. You will be verifying, in case of database, if nothing was deleted, if no table was dropped, if there are no unnecessary rows, if you didn't expose something, if the values are correct. There is plethora of things that you might be checking here. So how to do it? One option, use a bash script. If you are using something like PSQL, have a bash script somewhere in your file system, in your version control system, and mount it, as we did previously with the fixture. Another option is you can build your verification as an application, package it inside of a Docker, and run that image. That's also a viable option, and it will differ from use case to use case. I like using bash for things like using PSQL to verify database because it's simple enough. If I need to verify something complex, if I need to do some calculation, if I need to correlate things, I would probably build an application that will do that for me. But no matter which way you go, it will work the same way. The only thing that will change is your command and image. The rest stays the same. We will still depend on the SUT trigger to complete successfully. We will still use the same environment. It will still be as simple as that to structure your test cases. The same thing about S3. You can use AWS CLI to do things like AWS S3, list the bucket, verify its content. If you need something more complex, bash script is way to go, or application with separate image is your way to go. This was single test case. And now, let me ask you a question. Was it too much details? Was it not enough details? If it was too complex, raise your hand. No hand in the air. I'm happy. So we will continue with the same pace. Now, if we know how to build a test case, we need to figure out how to run multiple test cases. And there can be two different cases. You can run them in parallel, but if you are running them in parallel, you need to make sure that first, they are orthogonal. If you are running two test cases that are trying to modify the same row in the database or trying to modify the same file, you are up to problems because you will have race condition. So make sure that test cases that you run in parallel are orthogonal. And when running multiple test cases, it's very easy to lose track what is what. You need good naming convention, what trigger corresponds to what service in SUT, because you can have a lot of services in SUT. Like we did some time ago, content delivery network. And in content delivery network, you have different nodes. You have something that lets you upload things. You have something that checks consistency. You have something that synchronizes between different buckets, and so on and so on. So you need to have a good understanding, and you need to have traceability of these different pieces of the software, how you trigger them, and how you verify them. And in the examples, I will show you what is mine naming convention, and I hope it will work for you, but you can work your own as long as it's easy to track things and correlate them together from the report. And last but not least, we will be building the chains of test cases using depends on. So if something cannot be reflected as a parallel test cases, but we need to chain them one way or another, depends on is your friend. So we will be trying to build this scenario where we'll have some kind of setup. We'll trigger two parallel chains, trigger some upload, upload 1, upload 2, and then we will delete the file that was uploaded in upload 1. Basic example, two different test cases running in parallel and then one chained sequentially. And in that case, let's trigger the applications. We'll have, again, two triggers. They do not depend on each other, so they will run in parallel. We are using our image, whatever that is. We are giving it command to upload to some destination. Simple as that. It is supposed to do the work. Here we are treating it as a black box. We don't really care what it does internally, but we care about the output of it. So we are creating the services for verification. These services will then depend, obviously, on the triggers that we created. And here, the verification must correspond to the right trigger. That's why I told you that we need to have good naming conventions, because otherwise we'll quickly lose track. Since we had here only trigger 1, trigger 2, it's simple. If it gets more complex, I would call it trigger upload 1 and trigger upload 2. If there are multiple services, I will try to make sure that the name of the trigger and the name of verification has the name of the service in it and what kind of scenario we are doing. Like trigger uploader shall upload the file to right location. This is this kind of a test case. And this name you are later on using in depends on section to verify things. Now that we did already finish with that part, we will be trying to delete something. And when we will be deleting something, then we are doing the same. So we have trigger delete 1, we have the command, but now we need to link it to our step that created the file. And how do we do it? So if we go back, we have here trigger 1 that is uploading the file, and we have verification upload 1 that is verifying if the file is there. So we could link it to one of these services. Which one should it be? Of course, it should be the verification step, because if we try connecting it to trigger 1, then we will create the race condition where verification and the delete are running in parallel, and that is asking ourselves for a problem. So we should link it to the verification of the upload. When we have verified that upload completed successfully, we can trigger delete. And there is an error on the slide because I didn't add that depends on. And this is a good example of an error you can make when you are creating the services. This would have run too early. It would have run in parallel with the rest, and the test cases would fail, not because the system under test is broken, but we made an error in configuration of test cases. And to add injury to an insult, I have made another error here, and I am depending on the wrong service. So verification delete is depending on verification upload 1. That's another type of an error. Missing a dependency is an error, but another error is depending on wrong service. We should have depend on verification upload in the trigger, obviously, and in verification delete, we should depend on the trigger delete. And here you have also a very simple example of bash command that you can run to verify things. Since we were just trying to delete file, it's enough to check if the file exists. If it exists, we exit with 1. That means this service failed. If it doesn't exist, we exit with 0. It means everything is good. So that is how we can report errors from our test cases. It ends with either 0, it passed, or anything other than 0, it failed. So now we know how to structure test cases. Let's see how that structure can be reflected and integrated as a JUnit report so that your CI/CD will understand your test cases. If you want this is an example of Jenkins, but if you want any other tool to give you a report like that test case failed, we skipped some, we passed some, there was some stack trace, there was some standard output, we can do it. Docker Compose doesn't give you that one for free, but it's really easy to map things between two different formats, and Docker Compose gives you a lot of tools around running services that will let you build this kind of report and in the end figure out easily what failed, why it failed, and what were the logs. And when you are running your different pieces like SUT, verification steps, setup steps, the logs that you are creating there will help you figure out what went wrong. Then you can figure out which service failed, then you can figure out what you should be debugging. So it is quite simple then to pinpoint an error to single application, to single scenario, and figure out how to fix it. So let's see how it works. We will be using Docker Compose PS-all. It gives you statuses of services. So we have here our fixtures and simulators. They shouldn't fail ever, because if they fail, then it means it doesn't make sense to run any tests. And in this example, it says up 30 seconds, 31 seconds. That means these applications, these services are still running. So we are good, they are healthy, they are running. Then we have triggers. They have exited with code 0. That means they did their job, exited, everything is fine. It gets interesting in verification step because we have a step that failed. Verification upload 1 exited with something different than 0. That means that very step went down. And last but not least, some services that were created. They never exited, they are not up, they were created. And this is a list of services based on what we did in the previous example, where we had 2 uploads and we had changed the delete to the first upload. And since verification upload 1 failed, if the trigger delete depends on it, it couldn't have run ever because its precondition failed. That's why it's created here, but it never ran. And let's see how that translates to what we have in the JUnit report later on and what we will be exposing to our CI/CD system. JUnit report is a simple XML file. It has test suites. You can name it however you like. You can have multiple Docker files being different test suites. You can have integrations tests and performance tests as different test suites, for example. And that's what we are doing. And these test cases will be running in different environments. For performance, we'll be running different services than for verification. So having separate test suites for them, like here we have integrations tests, lets you separate on the high level of things. And on the lower level of things, what we will be doing, we have this trigger 1 and trigger 2. They have exceeded with 0, so we are adding test cases trigger 1, trigger 2. We are not adding any content to that node. We are just closing it immediately. That means that test case passed, so we are good. It gets interesting here where we have a failed step, where we have a failed service, because first of all, we need to tell the unit and later on the CI/CD tool that there was a failure, that we have found a failure. And we can use different types. Assertion error is one of them. It can be something else. It's up to you and what this step does for you. The fact that we have used the verification upload one means that we can use that name in the failure message somewhere to easily link things together. And with simple regex, you can later on post-process it and give it a more verbose name or whatever you want. But what's important here, we would like to know what happened in that test case. So we need some kind of a call stack, but we'll get to it because we have still two services that were never run, that were created but never run. And we can either consider them skipped or failed. It's up to you how you want to think about them. In my opinion, they failed, because if they didn't run, I had no chance of checking if my application works. That means that this scenario is unchecked. It could have been considered skipped, but skipped is often used to mark expected failures. Like this is a step, or this is a test case that is known failure and that I want to skip. So I rather lean towards considering them failure. It never ran. That means this part of application never was checked. That means I cannot trust it. So a failure. And going back one step, the call stack. This is what will let you figure out things. When you look at your report, when you look at your Jenkins or whatever that is, this is where you will first be looking for any errors in your test case in your application. So the simplest thing you can do is just ask Docker Compose for the logs of that service that failed. And it will give you, and you can paste it, and then you will see the log in your Jenkins, TeamCity, whatever you use. What you can do further, because this is the simplest thing you can do. What you can do further, since you have Docker Compose with all the depends on inside, you can figure out what services this one depends on. Like verification upload depends on trigger 1 depends on SUT. So you can build that chain and ask Docker Compose for logs from all these services sorted by time, and then you will have an interleaved log of everything that happened. It will give you more context. And now it's really up to your use case. If your applications are creating a lot of logs, it might be too costly to print everything out there. Or if you have very long chains of dependencies, it might be blurring the image. And then you want just the logs from this verification service. If you write your verification service in a way that it is logging extensively what it's doing, what it's expecting, what the expectation failed, it should be enough. If your test case, if your environment is simple, you can go through the chain of dependencies and have more context. It will probably let you find the error faster, and it will make it easier to write verification steps because you will not have to care that much about logging in verification step because you will have the logs from trigger and SUT itself. Up to you, depending on the use case. Myself, I am leaning towards this option where I only print the log of the verification service, and I'm taking care that it's very detailed, but different use case, I might change my mind and try to do things differently. So that's all I had for you today. It's time for questions and answers. Thank you very much, and giving it to you.
Hello. Hello. So thank you for a great talk. It was a pleasure to hear you. I have one question. You didn't said anything about test teardown. So after running the test, you left like S3 simulator running and database running. How will you handle that?
Oh, that's a very good question. Thank you for it. Basically, what I would do, anytime I run my test cases in my local computer, this is very great value of using Docker Compose. You can run all this in your local computer. You do not have to do it in Jenkins. Anytime I run them in my local computer, if something fails, I keep services working. So if they are working, I can introspect things. I can connect to that local stack and check what's in there. I can verify the logs of my services because they are still running. If I have exposed ports, I can do something about it. And in CI, if I don't need this kind of live debugging experience, you simply call Docker Compose down. If you are mounting volumes, you just tell it minus minus volumes so that it removes them, and that's it. It removes everything, and you are starting fresh. Does it answer your question?
I'll ask two questions. The questions, firstly, what's the difference between the configs and the volume on the Docker Compose?
So the conceptual difference is that config is something small that you mount as a configuration, and volume is a volume that the application can be manipulated. Like if you need something where you will be storing intermediate data from application and you don't want to mount something from your file system and you don't want to introspect it, that would be volume. And if you want to pass, for example, config file, that would be config.
And the second question, how to make sure that the simulators or servers are ready for the trigger?
That's a very good question. I have mentioned during the presentation something called health checks. This is a little bit more complex topic, and I didn't want to go down into it because I suspected that half of the room wouldn't know Docker. But since we have time now, we can talk about it. So with any service, you can define health check. And you are the one who tells what health check does. It can, for example, ping the application. It can, from time to time, try to execute some simple SQL function just to make sure that the service is healthy. And then in the depends on section, you wouldn't just use service started, but you could have used service healthy. And that gives you certainty that the service is ready to actually process your requests. Welcome.
Hi, thank you for the talk. I would like to ask you about the depends on section, because if you would have a case where you have multiple orthogonal test cases, is it possible to define like an array of them, or do you need to define each of them separately as a different trigger and step in your compose?
Depends on section can take multiple entries. So if we will go back, so we have depends on here, and so we have one entry, but we could have many. So
no, sorry. I mean, if you have one, they would all depend on one step, but you would have like 100 different test cases that should start after the build finishes.
Okay.
And then maybe there's a nice way to trigger all of them.
If you have 100 steps depending on one, like SUT, each of them would have to have depend section pointing to SUT. There is another case where you have end-to-end mapping. And this is what things are getting a little bit more tricky, because you have like N services, service for upload, service for consistency check, whatever, and you want your trigger to be you want your triggers to depend on it. So you have end-to-end mapping. You want to check the whole array. What you can do is to introduce an intermediate step, like SUT ready service. It will do nothing. it will just be bash exit 0, but it will have all the depends onto SUT services, and then your triggers need to depend only on that one service. So this way, you are changing N to M mapping into 1 to N and M to 1. So it becomes a little bit simpler, but it also becomes a little bit more blurry then, because if one service fails and these are not created, then also this one in the middle will not be created, so you lose that linkage. So you don't know that this exactly one failed. And it also creates on you some kind of a false sharing, because you might have test cases that want to test only part of the services that do not depend on everything. Like uploading a file wouldn't really depend on a consistency check. By creating this kind of a false weighting, you are making your test cases a little bit slower. So it's a decision to make. If you want to go for simplicity and you can take that burden of increased time, it's okay. If you can't, you can make it a little bit more complex, but squeeze the execution time a little.
Okay, thank you.
There's also one final question to you from the application, and the question is how to finish simulators after tests.
Oh, this is something that we already heard
okay,
before.
okay, thank
Docker
you, sorry.
Compose down is the way to go.
Okay, thank you very much, and sorry for my lack of knowledge.
No worries, no worries. It's a very good question, so it's better answered twice than never.
Thank you for handling that. Okay, huge round of applause for our presenter today. Thank you very much.